In this video, we'll be learning about how to balance chemical equations. First of all, why do we balance chemical equations? We balance chemical equations in order to obey the law of conservation of matter, which in simple states that matter cannot be created or be destroyed. In chemical reactions, however, this law basically means that the total mass of all the products should be equal to the total mass of all the reactants. With this example for the reaction of water, we can see how the number of each hydrogen and oxygen atom remains the same during both sides of the reaction, even though they might arrange themselves differently in compounds. Now, how do we actually balance chemical equations? The first step is to write the unbalanced equation. Here, we have a simple example of an unbalanced equation for the formation of copper oxide from copper and oxygen. The second step is to find the number of atoms of each element on both sides of the equation. Because there's no number before or after copper, we can write that there's only one copper atom in addition to the two oxygen atoms as reactants. We also have one copper and one oxygen atom in the products. In the third step, we have to change the coefficients of each element and molecule in order to equate like atoms in both sides of the equation. The coefficients are the numbers that go in front of the species, and the subscripts are the numbers that come after a symbol and below. For example, the number 2 below oxygen. We have to change the coefficients in a way that will balance the same element in the other side of the equation. However, we cannot change the subscripts, as doing so will change the substance itself, making the chemical equation wrong. Here, we can see that the copper atoms are balanced, whereas the oxygen atoms are unbalanced. To balance the oxygen atoms, we have to multiply the smaller number with a number that will make it equal to the other oxygen atom. In this case, we are multiplying 1 by 2. By adding the number 2 coefficient in front of the product copper oxide, we have to multiply both of the atoms in that molecule. Therefore, we also now have 2 copper atoms in the right side of the equation. To balance this change, we must multiply the copper atom in the left side of the equation by 2. And now the equation is balanced. Let's look at some more unbalanced chemical equations examples. You may pause this video at any time to attempt completing the balancing by yourself. First of all, the reaction for the formation of water. After writing down this unbalanced equation and counting all of the atoms on each side, we can see that we have an unbalanced number of oxygen atoms and balanced hydrogen atoms on both sides. To balance the oxygen atom on the right side, we multiply 1 by 2. We need to remember that by adding a coefficient in front of a molecule, we have to multiply the other atoms in the same molecule with the same coefficient. Hence, by multiplying the coefficient 2 with the existing 2 hydrogen atoms, we now have 4 hydrogen atoms in the left side of the equation. The hydrogen atoms are no longer balanced. To balance this change, we must multiply the hydrogen atom in the left by 2. Next, we have a more complex equation involving multiple elements. In the right-hand side, do notice that we have 5 hydrogen atoms in total, 4 from silicic acid plus 1 from hydrochloric acid. After noting down all of the numbers of each type of atoms on both sides of the equation, we have to calculate the coefficients needed to balance this equation. In a more detailed equation like this one, it is best to start balancing the atom that shows up the least number of times on one side. Then, move on to the atom that shows up the second least number of times, and so on. Consecutively, we should try to leave balancing elements that occur more than once on each side of the equation for the last. Most commonly, these are oxygen and hydrogen atoms. Here, we see that in addition to silicon atoms being balanced on both sides, it is also best to start balancing the chlorine atoms first. To balance chlorine in the left side, we have to multiply 1 by 4. Now that we've input the number 4 as a coefficient in front of hydrochloric acid, we must also multiply 4 with the hydrogen atom in that molecule. We now have a total of 8 hydrogen atoms. Next, we should balance the oxygen atoms as it doesn't occur in more than 2 molecules, unlike hydrogen. To balance the oxygen atoms, we multiply the 1 atom of oxygen in the right by 4. This, as a result, also balances the hydrogen atoms. You may pause this video and attempt to balance the next equation. After noting down all of the individual atoms and assessing these numbers, we can see that we have a balanced number of aluminium atoms. Firstly, as we balance the chloride atoms, we also now have 3 hydrogen atoms in the left side. In order to now balance the hydrogen atoms, we must multiply each hydrogen on each side of the equation with a common multiple, which in this case is 6. Now that we have 6 hydrogen atoms in the left side, we also have 6 chlorine atoms. To balance this change, we must also multiply 3 chlorine atoms in the right by 2. By inputting the coefficient 2 in front of the aluminium chloride, we now have 2 aluminium atoms in the right side of the equation. To balance this change, we must multiply the 1 aluminium atom in the left by 2. Now the equation is balanced. In summary, we have learned the reason why we balance chemical equations, the definition of the law of conservation of matter, and the steps that are needed to be taken when balancing a chemical equation. This video only simply explains how to balance these equations. Therefore, do notice that the more practice you do, the more fluent you'll be at doing so.